Do you want to use the pointer? Do you want to use it? Then the lighter continue. Okay, the next team is team number 3. So you can start when you are ready.
Hi everybody. We are group 3. Me and Ikram. We're gonna present the air-drawn smoke detector. Our project outline is statement, issue, and object, theory, practical, and demonstration, also challenge, problems, and the business action. The statement issue. US Fire Department state that the fighter face serious difficult and health risk, for example, heat, flame, and many diseases caused by the smoking or other gas like methane. Our objective is to help.
Just speak a little bit louder.
Objective: help the fighter to explore the fire in the early stage, control the sense of the smoke and gas without risk, and record the video stream for the fire. Theory: our project consists of 2 parts: drone. The Barrett, which we choose a drone because it has many features, camera, and we can code it. And the other part is the software. We use Y drone. It's a frame work for the control the drone. So the next part is my
Okay, for the smoke detector circuits, we use the M2U02024 sensor because it has a high sensitivity of LPG, propane, hydrogen, and other gases. And we use the XB serial 1 because it's easier to use and popular. And we use the M2U02024 Arduino. We choose it because it has an interface for XB and it's more efficient for the XBs. And the practical part, step 1, we did the programming the drone. We used the Y drone library. We use this because it's easy to use, based on Java language, and Java language is, we know more about Java. It's the language we are familiar to. And in addition, we use the NetBeans interface as IDE, which provide more functions to work with the graphical interface. For the step 2, we download the Arduino software. It is a software, free software. We use it to program the Arduino and get sketches to Arduinos. And for the step 3, we downloaded the XCTU platform, and it's also a free software to configure the XBs. And for step 3, we start building the sensor circuits. We build the sensor. We do the following: connect the M2U020 sensor with the sensor carrier, adjust RL M2U020 sensor to the 10 kilo ohms to satisfy the sensor, and we connect the VCC pin on the M2U020 to 5 volts transformer. And finally, we connect the ground to the ground and out, and then another to digital converter. And for step 4, we start building the regulator circuits. For this function, is to transfer the 12 volts of the drone battery to 5 volts of the operation of the sensor. We use the resistor, connector, 1K resistor, we use capacitors, and in addition to that, we use the switcher and LED to get that the power is on. And for step 5, we start testing the communication circuits, and we connected the pin A0 of the Arduino to the sensor, which read an analog data and transfer it to digital. And finally, we connected the XB to the Arduino. And the step 6 is to connect everything. We use to get everything inside this box as a cover to all the components. And let's demonstrate.
How are you going to demonstrate? Can you explain?
Yeah, for the demonstration, we're gonna we cannot get the Arduino fly, and we can just show the sensor that it works, and we can show the concentration of the gases it gives us, and for
You are not going to fly here.
yeah, we have this Arduino is connected to the PC to get the data from the sensor. Okay, right now it's getting no gas, no no CO, no smoke, nothing. And if we did a little bit of gas here,
Smoke one.
yeah. You have to put it.
Mm.
Yeah. It's changing the. With the lighter, it's not like the level of the gas. It's not high. That's why we cannot get like a big data. And we can test it outside. It can give us the signal. It can send us the information from outside.
Do you have any video?
We just we did the video, but this is just the video that the Arduino catch, not we didn't do the video outside.
Mm.
So this is some pictures from the Arduino, and this is a video from the Arduino camera. the challenges and the problems we got in this project, we had a challenge. We took like 2 weeks or 3 weeks just to get the two XBs connect to each other, and the problem was that the both XBs has to work with the serial mode, and for the problem we had is the weight of the components. The drone cannot manage the weight of the drone of the components, and we try to get a fly. It flies like just like middle of the and then goes down. And for our business plan, the goals and strategies. For the short-term goal, we use the quality and the feature of our products and advertise it like to be known in the market. And for long term, we're trying to expand the product to international market. And for our strategy is to work hard to improve the functionality of the product and get more functions for the gas and for the smoke. Like now we have just 3 functionalities: the LPG, the CO, and the smoke. We can get more methane and other gases. And for market analysis, our target markets will be the fire departments, some security departments, some laboratories that work with the chemicals, and our product can help them to get the concentration of the gases inside the buildings, and it will help the fire departments to lower the risks and the diseases from the smoke and the flames. And for our competitors, many exciting smoke detectors are available in the market. Their prices vary from 300 to 2,000 and depend on their unique features. Well, we didn't find like direct competitor for our product because it's connected to the drone. And here is the startup cost. We have all the equipment and the unit cost, and the final cost was 327,106. And later on we can add more costs like the manufacturing cost or advertising cost and other things. And thank you. Do you have any questions?
Any question or suggestion?
I'm very happy to see smiles on their faces. It's
You know.
big contrast from last time, and good work in the midterm. Yeah.
Actually, there were 4 members in this team, but 2 of them left, so it was a very hard time. And I have some suggestion. So nowadays, even the FCC, right? They try to regulate the drone policy, which means the drone will be very important in near future. As you know, the Amazon would like to use the drone to deliver the item. I heard that China right now they use the drone for delivery, which means that if we have a time, the future, when the drones are flying everywhere with safety, then if we can put such a sensor, like the temperature, or the very simple sensor, like the the carbon monoxide level or the dust level or something, then you can provide such information to nearby people directly. That's the most accurate information. Also, if you have the 1,000 drones or flying away, who knows whether it looks like the car on the road, and if drones, the 1,000 or the 10,000 drones are flying away, so it can be the very important source of the data analytics. So you can analyze such as the sensor data, and so definitely there might be.
I think if we used another drone that's more hard.
Yes. This
can,
is a cheapest toy style.
It can fly and get inside the place.
And also same company Parrot released the recent version of the drone, so which is called Debug. I know that there's no well-known API, but in case somebody make the API of that will be better, and more capacity to the kit, the additional accessory. Any other? Okay, thanks so much.